Hello everyone. So let us see the general measurement system component with respect to signal conditioning for sensors and transducers. So here is a block diagram or a general measurement component system, which we can say that. So it consists of a transducers, a signal conditioner. So here, which is an important part over here, we will discuss in detail about the signal conditioner or conditioning, how it happens, and finally the data presentation. So basically in the first stage of the instrument, the system detects the measure end. So that is nothing but the input physical phenomena, which is also called as a measure end, which is termed as a detector or transducer stage. So where detects the input signal, and the output from the first stage needs certain modification before it comes to the compactable at the data presentation stage. The necessary modification is carried out in the intermediate stage, which is called as a signal conditioner. Most commonly, which is referred as a signal conditioner stage, which condition the signal before presenting over here. The last stage of the measurement system, which consists of indicating or recording or displaying or data processing element, or it may consist of a control elements also. So basically the measurement of a dynamic mechanical quantity, which can be place special requirement on the elements of signal conditioning stage here. So whenever we have a mechanical input, so where I need to convert that to the different form of signal before presenting, in that case the signal conditioner will place a major role here. So finally it consists of a amplification, which is not shown here, which everything happens within a signal conditioner. We will see in the next slide here. So before going to signal conditioning and its necessity, let us see why the signal conditioning is very, very important. As already mentioned, that the signal condition may be defined as a process of modifying the output signal from the transducers into unstable and satisfactory signal using amplification, attenuation, non-linearization, linearization, multiplication by other function. So all this will happen within a signal condition. Amplification may happen if the signal is weak. The attenuation can be done, or non-linear. If non-linear signals are there, it can be linearized, or vice versa. And any multiplication factor should be done. Everything happen within a signal condition. That is the reason why signal condition is important here. The signal conditioning of a signal condition may be due to the following reason. The necessity may be following reason here. Signal condition. The signal may be too noisy due to the electromagnetic interference. In that case, I make use of a signal conditioner. I remove this noise and I give a proper signal at the output side. And signal may be too small, usually in millivolts range. In that case, amplification is required. We may amplify the voltages or current signal to the required ranges so that it can be easily measurable. And signal may be nonlinear and required to be converted to the digital form. So I have an nonlinear signal, I want to convert to digital form. In that case, I make use of a analog to digital signal, or vice versa, digital to analog signal. So if in this case analog one, we go for a analog to digital signal, or digital to analog signal. All the two things can happen, vice versa. And it may be required to improve the quality of a digital signal. So quality of a digital signal, if you want to do that, in that case also the signal conditioning will be required. And coming to the process adopted in signal condition, I said that the signal will be conditional. What are the process will be done within this? So if you look at here, the first one, the protection. So the protection, the range of the output signal from the transducers may be so high, and that might be where it may damage the next unit or element which need to be protected. In that case, the protection will take place. The signal, the output signal, where if it get damages, in that case I need to transmit the signal properly so that the same input which you measure should be presented at the output. That is very, very important. The protection is very, very important. In this case, we make use of like a step-down transformer or voltage limiter circuit, etc. Those things. The second one, getting right type of the signal is very, very important here. The output signal of a transducer is of an unlocked type. If it is an unlocked type, and if you need to convert to the DC voltage or current, DC voltage or current, I make use of a microprocessor. Of a digital nature, which will be used to convert the analog signal to the digital signal. That is also possible. And getting correct level of signal. The level of output signal may be too small. In that case, if it is in terms of millivolts, I want to increase that signal, so I may make use of amplifier over there, and I want to convert to analog to digital signal. So all this can be done in using a op amp or an amplifier. That will be op amp, and because of a operational amplifier, or which are widely used nowadays. And elimination of interference. This is very, very important. Some undesired signal or disturbance, which are noise or disturbance due to electromagnetic interference, may be associated with the output signal. These need to be eliminated. We can remove this by using the filters. So filters are widely used to eliminate this kind of a signal. So finally, manipulation of the signal. The output signal may be non-linear in nature. So these need to be linearized and vice versa. So that is where we manipulate the signal. This is regarding my signal conditioning system, how it happens, what are the process will be adopted to do the conditioning of the signal. So thank you.